Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Rambus with Steve Wu, who's going to talk today about the impact of more data and what that does to architectures. Steve, so now we've got all this data coming in from all these different sensors everywhere. What does that do in terms of changing both the architectures as well as the focus on data itself?
Sure, that's a great question. Architecture is all about balance, and you really want to try and make sure that you're meeting the needs of whatever the application is. Today's architectures are more data centric, and so you're starting to see some evolution in terms of what's going on in the processing as well as in the memory systems that stores the data. For certain types of systems, you're seeing novel kinds of processing come to market. One area that you see is machine learning, where people are building specialized chips to do the processing for neural networks much more quickly and in a more power efficient manner. And then on the memory side, for storing all of our data, we're seeing a lot of interest in changing the structure of memory systems. The traditional memory system has a CPU and it has its own on-chip memory. It's got a larger amount of DRAM. It's backed by some solid state disk and then eventually even more hard disk. But what we're seeing is this emphasis on improving performance and becoming more power efficient. It's causing there to be places in this memory hierarchy that people are looking to insert new technologies.
And this is where we're starting to see some of the phase change memories, spin torque type of memories.
That's right, yeah. Traditional NAND flash, people are looking at that as a way to augment DRAM and to treat it more like memory. There's other efforts as well to look at some of the newer types of memories, some of the storage class memories that are coming into the market as well.
So what happens with the entire compute architecture here? How does that change based upon the fact that you now have different types of memory? You have some on chips, you have some off chips, some in package, as well as much more data to process as well.
Yeah, that's a good question. Really what's happening is it's causing there to be more degrees of freedom in how you design an architecture. And so some of how this will play out in the longer term is really to understand what use cases will become the most popular and which ones will be the ones which eventually drive the direction of architectures. Today, I think it's still an open question. There's a lot of different directions it can go. And partly that's because it's in the early days.
Are the two main pieces of this the edge and the cloud, or is there more to it?
There's a little bit more to it, but I think the edge and the cloud will always remain as important pieces of that whole ecosystem. There's the endpoint devices themselves, and then there's also more specialized applications that we might find. There can be things like automobiles that may have their own specific architectures, and in almost the same way that phones kind of came up with their own type of architecture.
One of the things that's changed is the value of the data is going up as well. So as you start getting more of this data, you can start seeing trends. You can start picking up things that you didn't get out of smaller amounts of data that we used to have. What happens with security?
Yeah, so what we're seeing is that really the data and the insights you can glean from that data, as you mentioned, are becoming much more important, and there's a lot more value in that data. And so consequently, that's why the data is really what people are after. And so barely a day goes by where we don't read about another hack that's happened and a critical amount of data is lost. And so what we're really seeing is this growing need to secure the data itself. And really up until recently, security has been more of an afterthought. And people have tried to bolt it on to existing architectures, and that hasn't worked as well. And really, I think what people are understanding now is that security needs to be thought of as a first-class design parameter. It has to be something that's architected into a system from day one. And so treating security and understanding the principles behind what the security has to do as an important design parameter is really a direction that the industry is going to move towards.
So one of the things that's changed is that the mass market, things like automotive chips, for example, automotive systems now have to last for 10 or 15 years. Sometimes you see degradation of performance, you see aging issues that go on with chips and circuits. What does that do to the data? How do you secure it in that type of environment?
Yeah, I think that's all part of the challenge of thinking through security as part of your architecture. The data potentially can live many times longer than the actual architecture itself. And so in addition to thinking through a security architecture, you have to think through a data longevity kind of architecture as well. That data will have to be migrated forward over time. and it'll have to adhere to new security standards. And so that's really all part of the puzzle of trying to figure out how best to architect a solution that's secure not only from a processing standpoint, but also from the security of the data.
And that's been one of the issues with these new types of memory too, right? Is how long can it keep the data and keep that data intact without any leakage out of there?
Yeah, that's certainly part of this equation of understanding what you have to do from a security standpoint. DRAM holds the data, relatively speaking, a much shorter period of time than some of the storage class memories do. And so understanding and integrating in features that can support established policies for things like privacy and the right for data to be forgotten, they all have to be architected into the system.
Let's go back to the explosion of data here, because I think that's one of the big issues that's driving a lot of the industry these days. What does that do to the interaction between the processor and the memory?
That's a good question. So what we're seeing again is a resurgence of interest in improving memory systems. And the number one thing we see with the explosion of data is a desire to have more bandwidth to and from memory. And so what we're seeing now is we're seeing applications, a lot of mainstream applications, looking more towards higher performance memory solutions. So, traditionally they've looked mostly at solutions like DDR, but now they're willing to consider some of the more advanced memories, things like HBM and GDDR as well.
And HBM typically was associated with a 2.5D type of architecture. Is it starting to move into a planar architecture as well?
There'll definitely be a desire to try and put it in those types of solutions. Those will tend to be lower cost and more mainstream. And so there'll always be, I think, an effort to try and move it there. But I think it's best suited in kind of the 2.5D architecture. It kind of gives you the best of all the benefits that are there.
Steve Wu, thanks for a great explanation.
Oh, you're very welcome, Ed. Thanks for the time.